Hey there, awesome physics students. Let's talk about static equilibrium. Now, we know that forces cause acceleration, and don't forget the property of mass in the middle. We also know that torques cause angular acceleration. But what if there's no acceleration? What if there's no angular acceleration? What does that tell you about the force and the torque? Well, if there's no acceleration, that tells you that the total force as a vector is zero. That is, this is actually two equations here, if we think about it in just two dimensions. This is telling you that the sum of the forces in the x direction are zero. The net force in the x direction is zero. And the net force in the y direction is also zero. Now these are independently zero because what happens in those two dimensions are separate. They don't mix. Similarly, the angular acceleration, if that's zero, that's telling you that the total torque must be zero. Now you might ask, torque about what axis? This is true if there's no angular acceleration. This is true about any axis. So this is a specific situation with static equilibrium. So you can choose, you're free to choose any axis to sum your torques, and you will always get zero. So really we have three equations if you do two-dimensional problems like we're going to do. We have two x and y, and then we have a third torque equation here. Typically, it's advantageous to put your axis where there is a force that you do not know about and do not care about, so that when you sum your torques, that force will not come into the equation of torque and you won't have to deal with it. We'll see some of these when we do some of the examples. All right, bye.